Ever watch a plane soar through the air and wonder, like, how's that even
Oh, it's
possible?
magic, right. But it's the magic of aerodynamic.
Exactly. And today we're diving deep into what it takes to be an aerodynamics engineer. We've got some awesome insights from RoleCatcher.com, a website that's basically a gold mine for career advice.
It's a career that blends serious technical chops with a surprising amount of creativity.
Okay, so not just crunching numbers all day.
Definitely not. It's about problem solving, pushing boundaries, and making things move through the air as efficiently as possible.
Love that. So RoleCatcher gets into the nitty-gritty of what these engineers actually do. What stood out to you?
Well, they use this term aerodynamic analysis, which sounds pretty technical,
Oh, jargon alert.
but it basically boils down to this: making sure anything designed to move through air, like planes, cars, even wind turbines, actually performs the way it should.
So it's got to work in the real world, not just look good on paper.
Exactly. It's about fuel efficiency, speed, stability. And the guide really emphasizes the collaborative aspect. You're working with a whole team, other engineers, clients, to make sure those designs are top-notch.
Teamwork makes the dream work. I bet communication is key in this field. One tiny miscalculation and
Disaster. And speaking of calculations, RoleCatcher also highlighted the research side of things. It's not just about applying existing knowledge. These engineers are pushing the boundaries, researching new materials and how they hold up at high speeds.
so it's not all just wind tunnels and equations.
There's a lot of that. But there's also a hands-on experimental aspect, especially now with the demand for eco-friendly transportation.
Right, sustainability is huge.
Exactly. And RoleCatcher actually points to a very positive job outlook for this field, especially in those areas focused on efficiency and eco-friendly design.
Okay, so we're talking in demand and impactful. That's awesome. But let's get real. Every job has its pros and cons. Rollcatcher doesn't shy away from the challenges. What did they say?
Well, they're very upfront about it being a highly competitive field
Which makes sense. High stakes, big impact.
and high rewards. They definitely mention the high salary potential, but also the long hours and intense pressure that come with it.
There's that trade-off. That high salary always catches my eye, but that pressure part makes me think of nail-biting deadlines and demanding clients.
You hit the nail on the head. In this field, that pressure could be anything from tight deadlines to demanding clients to constantly needing to innovate under pressure. We're talking about pushing the boundaries of what's possible here, so every decision matters.
No pressure, right. You'd have to be pretty passionate about problem solving to thrive in that environment.
Absolutely. And that passion is going to need some serious skills to back it up.
Okay, so what does it take to even get your foot in the door? Rollcatcher has a whole section on that, right?
They do. A strong foundation in math and physics is a given. They also highlighted the importance of specialized software like NSYS and Fluent.
Okay, now those sound serious.
They are. These are the tools that allow you to design and analyze aerodynamic systems. Like you could have a groundbreaking idea for a new aircraft wing, but without these software programs, you wouldn't be able to model how it performs under different conditions.
It's fascinating. It's those little details that make this deep dive so valuable. Just hearing the names of these programs gives me a better understanding of what this work actually entails.
Exactly. And it's not all just hard skills. They actually list reading comprehension as a key skill. You're constantly absorbing technical documents, research papers, staying updated in a field that never stops evolving.
So true. Even for this deep dive, good reading comprehension is key. Got to keep learning, right? Speaking of learning and growing, let's talk about how someone would actually break into this field, because Rollcatcher seems to have a treasure trove of resources for that.
They do. And one thing that caught my eye was this feature they call reverse matching.
Reverse matching. Okay, now that sounds interesting. Tell me more.
So imagine instead of you searching for companies, the companies are searching for you.
Okay, I'm listening.
That's what this does. Employers on the platform can search for candidates based on their skills and experience. So if your profile aligns with what they're looking for, boom, they can reach out directly.
No way. That's amazing. Talk about taking some of the pressure off the job search.
Right? It's like having a personal recruiter in your corner.
I love it. What else did Rollcatcher highlight about actually getting hired?
Okay, their interview prep tools. Seriously impressive.
Oh, yeah, you mentioned that earlier.
They have a massive library of practice interview questions. We're talking over 120,000. And they're all tailored for specific career paths, including aerodynamics engineer.
Wow, over 120,000. That's a lot of potential questions. But I guess that kind of preparation would definitely help calm those pre-interview jitters.
Oh, absolutely.
Yeah.
Because feeling prepared can make all the difference. It's not just about memorizing answers. It's about knowing how to showcase your skills, your passion. And that can really help you shine in an interview.
Makes sense. So it's practice makes perfect, or at least practice makes you a lot more confident.
Yeah, exactly.
But shifting gears a bit,
Yep.
we've been talking about aerodynamics as one big thing, but I'm guessing there are different specialties within the field. It's not all just designing airplanes, right?
That's a great question. And you're right. It's definitely broader than just aerospace.
Because I was thinking, like, what about race cars?
Yes, exactly.
Formula One, NASCAR, all that.
They're obsessed with aerodynamics.
Because every little curve, every spoiler, it's all meticulously designed, right?
It all comes down to optimizing those aerodynamics, getting that edge in speed and performance.
So cool.
And it goes even beyond vehicles.
Yeah.
RoleCatcher even mentioned renewable energy.
Oh, wow. How so?
Think about wind turbine design. As we shift towards more sustainable energy sources, expertise in aerodynamics is becoming increasingly crucial in that sector.
That makes so much sense.
It's all about maximizing that energy capture, making those turbines as efficient as possible.
So you could be designing a sleek new sports car one day and a massive wind turbine the next.
Exactly. That's the beauty of this field. There's so much variety.
That's amazing. But with so many options, where do you even begin? Is there one clear path to becoming an aerodynamics engineer?
Well, it's not as linear as, say, becoming a doctor, but RoleCatcher does a good job of outlining the typical academic pathways.
Okay, so what do they recommend?
A strong foundation in STEM subjects is obviously crucial. We're talking math and physics especially.
Yeah, those seem pretty important.
Right. And most aspiring engineers will pursue a bachelor's degree in a related field, like aerospace engineering, mechanical engineering, aeronautical engineering.
So you're basically learning the fundamental laws of how things move through the air, right?
Exactly. It's all about understanding those principles.
Mm-hmm.
But RoleCatcher is also quick to point out that it's not just about textbook knowledge. Hands-on experience is super important, even while you're still studying.
That makes sense. But how do you start getting that practical experience?
Well, they highlighted internships as being incredibly valuable.
Oh, yeah, internships. Those are always a good idea.
Because imagine working at, like, an aerospace company while you're still in school, applying what you're learning in the classroom to real-world projects.
Wow, that would be amazing.
Right. That kind of experience is pure gold on a resume.
Absolutely.
And it's not just about the resume, it's about seeing those textbook theories come to life, right?
For sure. What other ways did they mention to build those practical skills?
They talked about getting involved in research projects. A lot of universities offer opportunities for students to participate in cutting-edge research alongside professors and graduate students.
Oh, that's cool. Getting to work on real research as a student.
Exactly. And some students even participate in design competitions.
Oh, wow. Design competitions. That sounds intense.
Intense, but amazing. It's a chance to really put your skills to the test, to collaborate with other students, and to learn from experts in the field.
That sounds like my kind of learning environment. You're not just hitting the books, you're actually doing the work.
Exactly.
So you're living and breathing aerodynamics, basically.
Ex-
I love it. So once you've got that education, that experience under your belt, what's next? What does RoleCatcher say about the actual career progression? Is it a pretty clear ladder to climb?
They actually break it down into 3 main stages.
Yep.
Entry level, junior, and senior aerodynamics engineer.
Okay, that makes sense. So each stage with increasing levels of responsibility and expectations, I'm guessing?
Exactly.
So starting at the bottom rung with entry level, what does that typically look like?
So at the entry level, you're going to be working under close supervision, learning the ropes, getting a feel for how things work in the real world.
Yeah, that makes sense. You're not going to be thrown into the deep end right away.
Right. Think of it like an apprenticeship. You'll be conducting analysis, assisting with design tasks, preparing reports, but you'll have the guidance and support of more experienced engineers to help you along the way.
It's like that saying, every master was once a beginner.
Exactly.
Yep.
And RoleCatcher actually provided an example profile of a typical entry-level engineer's background, which I thought was really helpful.
Oh, I love those concrete examples. What kind of qualifications and skills did they highlight?
Well, a bachelor's degree is a must-have, of course.
Yeah.
But they also emphasize that practical experience, even if it's just through university projects or those internships we talked about, is super valuable.
Yeah, it's all about getting your hands dirty, so to speak.
Exactly. And they also mention strong analytical skills, familiarity with software like ANOS YS Fluent and MATLAB, and a real eagerness to learn and contribute.
So even at the entry level, it's about more than just ticking boxes on a list of technical skills. You need that drive, that passion to really stand out.
100%. So then moving up to that next step, the junior aerodynamics engineer.
Okay, so what does that look like? More responsibility.
Exactly. This is where you start gaining more independence, you're performing more complex analyses, you're taking on more design responsibility. You might even be leading smaller projects. And a master's degree is often seen as a valuable asset at this level, as are industry certifications.
So you're not just competent, you're starting to specialize, build your expertise.
Right. You're becoming a more sought-after expert. And that brings us to the pinnacle,
The pinnacle.
reaching the level of senior aerodynamics engineer. This is like becoming the conductor of the aerodynamic orchestra.
Okay, I love that analogy. The conductor. What does that look like in practice?
These are the leaders, the visionaries, the ones who are pushing the boundaries of what's possible in the field. They have that deep well of knowledge, that track record of innovative designs.
So you're not just understanding the science, you're using it to create something new, something groundbreaking.
Exactly.
Wow. What does it take to reach that level?
Well, they described someone with exceptional leadership skills, someone who can not only come up with amazing ideas, but can also inspire a team to achieve them. And communication is key.
Because you've got to be able to explain those complex technical ideas in a way that everyone understands, right?
Exactly.
Yeah.
It's about painting a picture with your words, getting everyone on board with your vision. And what did their example profile for a senior engineer look like?
I'm on the edge of my seat.
Unsurprisingly, a PhD was a common qualification, along with prestigious certifications, fellowships. But beyond the accolades, they really emphasized the importance of passion.
There's that word again, passion.
It's not just about checking off boxes. It's about that genuine love for the field, that relentless drive to push those boundaries, to explore the unknown.
That's incredible. So the learning never really stops, even at the highest levels.
Yeah.
Speaking of learning, this deep dive has been so insightful, but I feel like we've only just scratched the surface of what RoleCatcher delves into. So we've talked about the career path, the skills, the importance of passion, but what about the day-to-day reality of being an aerodynamics engineer? What did RoleCatcher say about the actual work environment?
You know, one thing that stood out to me is that it's not all just like sitting at a desk staring at a computer screen, which some people might picture.
Yeah, you'd think it was all equations and simulations.
Definitely a lot of that.
Yeah.
But RoleCatcher really emphasized that it's a dynamic mix of office work, lab work, even on-site visits, which
Yeah.
sounds pretty cool.
On-site visits. Now that's what I'm talking about. What kind of on-site stuff are we talking here?
Well, for starters, those iconic wind tunnel tests.
Oh, right. Wind tunnels, where they put those scale models in and just blast them with air.
Exactly. They use those to analyze the aerodynamic properties of different designs.
So it's one thing to design something on a computer, but to actually see it fly in a wind tunnel?
I know, right? That's got to be incredible.
Totally. What other on-site tasks did they mention?
They talked about visits to manufacturing plants.
Oh, wow. So you get to see how these things are actually built.
Exactly. It's about observing the production process firsthand, maybe even troubleshooting any issues that come up.
That's so cool. So you're not just handing off designs and then that's it. You're involved throughout the entire process.
Exactly. It really highlights that collaborative aspect we were talking about earlier.
I love that. So it's a very hands-on collaborative environment. What about the office setting itself? Did RoleCatcher paint this glamorous picture, like beanbag chairs and ping pong tables?
Not exactly. More like a fast-paced, dynamic environment. They talked about often having multiple projects going on at the same time.
Okay, so it's not all fun and games. There's some serious work
Oh,
involved.
definitely. You got to be able to juggle priorities, meet deadlines, and, handle a certain level of pressure.
Makes sense given the nature of the work, right? You're dealing with complex systems, cutting-edge technology. There's a lot at stake.
For sure. And that brings us back to the people. Because RoleCatcher really emphasized the importance of teamwork in this field.
Yeah, it can't just be all about individual brilliance, right? You've got to work together.
Exactly. They talked about constantly collaborating with other engineers, mechanical engineers, electrical engineers, structural engineers. You got to make sure all the pieces of the puzzle fit together.
Like you can't design a plane in isolation, right?
Right. You have to think about how all the components will interact with each other.
Exactly. And on top of all that, there's the communication aspect, right? Like you said, you've got to be able to explain these complex ideas to other people.
Oh, absolutely. RoleCatcher mentioned having to present findings, both to internal teams and to clients, often in the form of those detailed technical reports.
So it's not enough to just be brilliant. You've got to be able to communicate that brilliance.
Exactly. Okay, so we've covered a lot of ground here about what it's like to actually be an aerodynamics engineer. But what about those who are just starting out? What did RoleCatcher say about growth opportunities in this field?
Yeah, because we talked about the whole entry-level, junior, senior career ladder, but is there room to, like, carve your own path?
Definitely. They emphasize that experience is key. As you gain more experience, you naturally take on more responsibility, which can lead to those more senior roles, like project manager, team leader.
So it's like leveling up in a video game. You gain experience, you unlock new skills, and you take on bigger and more challenging quests.
I love that analogy. They also stress the importance of continuous learning.
Which, as we've established, is huge in this field. There's always something new to learn.
Always. Whether it's pursuing advanced degrees, staying updated on the latest industry trends, maybe even specializing in a particular niche, that commitment to lifelong learning is so important.
It's like even when you reach that coveted senior aerodynamics engineer level, the learning never really stops.
Ever. There's always something new to discover, always another boundary to push.
That's so cool. Okay, but let's be honest, after all this talk about career paths and skills, I think there's one burning question our listeners are dying to know.
The million-dollar question.
Yep.
How much can you actually earn in this field?
You read my mind. Because we've established that it's competitive, it demands specialized knowledge. So naturally, you'd expect those factors to be reflected in the compensation. What did RoleCatcher have to say? Did they drop any hints about salary expectations?
They were a little vague on specifics, to be honest. They mentioned that salaries can vary depending on experience, location, the specific industry, but they did use the phrase competitive salary, which is always a good sign.
Competitive salary. That's HR speak for you'll be well compensated.
Hopefully.
But they did give a range. They mentioned that the average salary for aerodynamics engineers typically falls somewhere between $70,000 to $120,000 per year.
Okay, those are some numbers. Not bad at all, especially for a career where you get to play with wind tunnels and design awesome stuff.
Right. It's a good reminder that following your passion and developing specialized skills can lead to a pretty great life, both professionally and personally.
Absolutely. Well, this deep dive has been amazing. We've gone from zero to aerodynamic hero.
I know, right? From Bernoulli's principle to career paths, we've covered a lot.
But that's what makes these deep dives so much fun. It's about sparking that curiosity, getting people excited about different career paths, and maybe even inspiring the next generation of engineers and innovators.
Absolutely. Who knows? Maybe there are some future aerodynamics engineers listening right now, already dreaming up the next supersonic jet or revolutionary wind turbine.
I love it. And hey, if you're out there listening, keep dreaming big, because in the world of aerodynamics, the sky's the limit. Thanks for joining us on this incredible journey.
It's been a pleasure.
And remember, whether you're a student, a professional, or just someone who loves to learn something new every day, never stop exploring.